As a pillar of the economy, and even just our lives in general, the cement industry serves almost every sector of society, from civil construction and water conservancy to national defense. Looking back, the cement industry has gone through 4 stages, each spanning 10 years or so. Before the year 2000, traditional manufacturing dominated. After that, the industry saw its first wave of real innovation, with the introduction of automation. Later, it was overwhelmed by a new wave of digitalization, which is now transforming into the smart cement of 2020 and driving the industry to new heights. So what is smart cement? Before going into detail, let's take a look at cement itself. Cement is a powdery substance. It's rarely used alone. Mixed with water, it functions as a binder, which sets, hardens, and adheres to aggregate consisting of materials, such as sand and gravel. Cement is a product born out of multiple sectors, mainly quarrying, manufacturing, and logistics. It is not easy for such a diverse industry to embrace Industry 4.0. Take quarrying as an example. Accidents occur in its harsh work environments from time to time, resulting in painful losses to both enterprises and families. Another issue is the cost of labor, which is increasing year on year, making it difficult to recruit and retain employees. Finally, cement manufacturing is complex, meaning production is inefficient and inspection is difficult. All of these have prevented the industry from stabilizing production, lowering energy consumption, and reaching higher efficiency. Thankfully, 5G is now in place to effectively overcome these obstacles and create better value for the cement industry. Let's go through the cement manufacturing process. It begins with quarrying. Limestone is a key material in manufacturing cement. It is excavated from open cast mine using explosives, and then transported by dump trucks or excavators to crushers. The crushers reduce the huge stone to chunks of raw material. This limestone is blended with other materials, such as clay, as they are transported to storage silos. This step is called pre-homogenization. These pre-blended raw materials are further mixed with shale and iron ore. The raw mix is then ground again into finer particles, also called raw meal, in a new dry process. From here, the raw meal undergoes homogenization, preheating, and then calcination. Homogenization is where the raw meal components are made uniform. They are then preheated to disperse fibers in the material, separate gases from solids, and prepare the raw meal for decomposition. After that is calcination, where the raw meal is introduced to a rotary kiln and heated to form hot clinker, which must be cooled before it can be stored. When cool, it is then mixed with different additives, according to the type of cement being produced, and ground into a fine powder to form the finished product. Finally, the product is packed and transported to customers. While this process is fairly mature, cement manufacturing has always faced a series of challenges. Needless to say, safety is paramount to the cement industry. Measures such as caution signs and patrolling have been taken before blasting to prevent people from lingering in quarries. However, blind spots are inevitable, unfortunately leading to accidents. After quarrying, terrain statistics must be updated promptly. But quarry location data, such as longitude and latitude, needed to be manually fed into a software application to generate the required statistics. This approach is time-consuming and error-prone. The industry is also facing a manpower problem. Unexpected weather conditions and dust can be harmful to the health of personnel. As a result, more and more people are reluctant to work at mines, resulting in a high employee churn rate and inadequate manpower. For instance, half the existing drivers possess less than 4 years of experience. In addition, The procedures of cement manufacturing need to be coordinated through a distributed control system. This used to rely on optical fibers and industrial Ethernet. However, the manufacturing process is scattered across different areas, with a large number of access points. It is rather expensive and difficult to deploy and maintain all of these network connections. And they can't just use Wi-Fi, as the concrete buildings in cement factories create strong interference, deteriorating reliability and increasing latency. Moreover, devices needed to be checked manually and periodically. For example, magnification has been used to check for cracks, but is not efficient and may miss critical issues or even put inspectors at risk. Finally, cement delivery needs to be monitored to identify unsafe driver behaviors and dust pollution, as worker safety is at risk. To address these challenges, cement manufacturers shift their eyes to smart cement, hoping to revamp the industry with 5G. What are the key requirements for smart cement? Smart cement involves smart mine, smart manufacturing, and smart logistics, each of them imposing different service requirements. In quarries, AI-powered drones need to inspect explosions and collect terrain data, and excavators and dump trucks need to be remotely controlled. Inspection needs to be automated throughout manufacturing and delivery to efficiently detect dust pollution, blocked material outlets, such as hoppers and dump valves, and damage and deviation of conveyor belts. A 5G industrial data network is a must for real-time data backhaul and centralized data processing. And AI should be leveraged to improve the efficiency and accuracy of manufacturing control. Speaking of AI, HD cameras need to be deployed to capture videos for in-depth analysis. In doing so, abnormal operations and unsafe behaviors can be identified effectively. In addition to automated services, smart cement requires that the network provide high bandwidth, low latency, and rock-solid reliability. For example, drone-assisted inspection and video content analysis usually require a bandwidth of at least 30 megabits per second. Unmanned driving demands a latency of less than 20 milliseconds, and an industrial data network must offer a reliability of 99.999%. 5G can satisfy all of these requirements. It is the ideal choice for smart cement. Automating manufacturing inspection, solidifying production safety, and upgrading networks. But to really get the most out of smart cement, 5G can be combined with MEC, with the UEG placed at the network edge or in the factory campus. The data for smart cement applications can be processed locally, yielding ultra-low latency and high reliability. 5G plus MEC makes cement manufacturing safer and more intelligent. In a 5G plus MEC solution, various types of data is moved onto the cloud to serve as valuable references for effortless monitoring and remote control. This solution has become the most favored option by cement manufacturers. How does 5G plus MEC empower smart cement? Well, to apply 5G plus MEC, 5G devices, including CPE and 5G modules, must be installed first, ensuring full 5G coverage across quarries, workshops, and other buildings. From here, 5G base stations and MEC need to be deployed as a base for network slices, which will be created to run different smart cement applications. Once traffic is generated for an application, the 5G core instructs the MEC system to perform a local breakout, and the traffic is then processed by local servers. Used together, MEC and network slicing can ensure low latency, high reliability, high bandwidth, and local data processing for cement manufacturing. So what exactly can smart cement deliver? It guarantees the safety of both personnel and devices during mine blasting, and updates terrain situations efficiently. Before blasting, drones capture HD videos across blast areas, and upload them to a cloud-based AI platform. to detect and alert workers of potential objects in the blast areas. After blasting, the drones capture videos again to update 3D terrain models. These models serve as important references for subsequent blasting and quarrying. This remote inspection application extends the diameter of the target area from 500 meters to 2 kilometers, while reducing the time required for manual operation from 2 hours to just half an hour, significantly improving efficiency. 5G greatly reduces labor costs and saves both energy and materials. It eliminates the need to deploy optical fibers, which is pretty difficult in cement factories and production lines. Along with cloud and AI, 5G provides the mobility required by campus inspection and security protection. Videos captured on the campus will be uploaded to the MEC platform in real time. The platform then leverages AI algorithms to analyze the videos, identifies every object in them, including personnel, devices, and vehicles, and triggers alarms for unsafe behaviors and faults through the AI warning platform, facilitating routine maintenance and fault diagnosis. With all the monitoring data for quarrying, manufacturing, and other production activities in one place, the AI warning platform improves the efficiency of monitoring and inspection by 3 to 4 times. Furthermore, we estimate it can help avoid 95% of accidents caused by human error and device malfunctions, while reducing on-site manual operations by 90%. Additionally, 5G enables remote control of excavators and dump trucks. This halves the required manpower and enhances quarrying efficiency by 20%. Last, yet by no means least important, 5G connects together every link in cement logistics. This helps cement enterprises perceive market trends, improve their supply chains, and estimate their sales. In the near future, smart cement will redefine the cement industry, stimulating business growth with a knock-on effect on social development.